In this build along tutorial, we'll be creating a custom wheel hub for the SparkBot. Once you've got FreeCAD open, begin by creating a new part in the Part Design workbench. From the Tasks tab, create a new body and a new sketch, and we're going to put this sketch in the XZ plane. Once you're in the Sketcher workbench, we're going to zoom into Quadrant 1, and we're going to create two line segments. We're going to create one line segment that is constrained to the x-axis, and we're going to create another line segment up above it. We're going to start by making these two line segments equal to each other, and we're going to left click on the right hand edge of these line segments, and we are going to constrain them to the same vertical plane. So now when I move the bottom line segment, the top line segment moves. We're going to set the length of these two line segments to 4 millimeters. Next, we're going to set the distance, the vertical distance between these two line segments to 25 millimeters. And we're going to set the distance, the horizontal distance from the right hand vertex of the bottom line segment to the origin. So left click the origin, left click the right hand vertex of that bottom line segment, and we're going to constrain the horizontal distance to 25.75 millimeters. Our two line segments are now fully constrained, and we're going to add a feature in between these two line segments. I'm going to grab the polyline tool, and I'm going to go to the right hand edge of that top vertex, and I'm going to left click on that vertex. I'm going to drag a line down, and then at an angle, down, at the complementary angle, and down, and then I'm going to right click to stop the polyline and right click to clear the tool. I want all of these vertical lines to be constrained vertically, so I'm going to select all three of them, and I'm going to choose constrained vertical. And the next thing I want these vertices above and below this offset part of the line, I want them to be constrained to the same vertical plane as well. Going to constrain the length of this top part of the feature, and I'm going to constrain it vertically to 1.5 millimeters. And the next vertical line segment here, I'm going to constrain that to 0.5 millimeters. And I'm now going to take these two angled lines, I'm going to set them equal to each other. And so now they're going to be of equal length. And I want this small little line segment to be no more than 1.5 millimeters away from this larger line here. So I'm going to make sure I've got both vertices on the end of that selected, and I'm going to constrain its horizontal distance to 1.5 millimeters. And if everything has been done right, if I grab this bottom vertex and move it up, then the top part of this outset feature will move symmetrically, and it does. So the next thing that we're going to do is we're going to move down to the bottom line segment and repeat this process. So again, I'm going to grab that polyline tool, go to the right hand edge of that bottom line segment, come up at a diagonal, up straight, up at a diagonal, and I'm going to stop here. So I'm going to right click to stop the polyline and right click to clear the tool. And again, I'm going to make sure that both my vertical lines are constrained vertically. And the next thing that I'm going to do is I'm going to make sure that the length of the different edges on this feature match the one on the top. I'm going to do that by left clicking on the top small little line segment there, And I'm going to do the left click on the complementary one at the bottom there, and I'm going to set them to be equal to each other. And I'm going to take these two diagonals here at the bottom, and just as before, I'm going to set them equal to each other. And now I'm going to join this longer line segment by left clicking on the bottom vertex of that line. And I'm going to join it to the end of this other diagonal. And so I will constrain coincident on these. And I'm going to set the length of this longer line segment now. I'm going to vertically constrain it to 14 millimeters. I'm going to take and set the length of this part of the outset line. I'm going to make it equal to the one above. I'm just going to zoom into it so I can select it. Zoom back out again so that I can see both of them. Left click on the bottom one, and now I'll set them so that they're equal. And the next thing I'm going to do is make sure that all the diagonals are the same length. So I'll left click on a top diagonal, left click on a bottom diagonal, and set it to be equal. And now we've got 1 degree of freedom here, and that 1 degree of freedom looks like the length of the outset here. So I'm going to make sure that this bottom protrusion sits at the same vertical plane as the top one. So there we are. I've selected those two vertices, and now I will constrain it so that it's on the same vertical plane. And now this part of our sketch is fully constrained. Just going to take and turn off the indicators for some of these constraints because they are filling up the screen space here. So in the left-hand panel here where it says constraints, I'm just going to uncheck the visibility for my different equals constraints, and that will clear up the screen a little bit and make it easier to see the lengths that I've set the different segments at. I'll do the same for some of the vertical constraints here. And my goal here is just to clear it up so that it's a lot easier to see the lengths of these different line segments. Okay. So here we are. That's nice and clear, easy to read. And so now we're going to add some more features to this. What we have created is the edge of the wheel hub, and these little insets here are where the edges of the tires will grip our hub. Now we're going to add some features to the center of the hub that are mostly aesthetic, but also provide some strength to the hub. We're going to do this using the arc tool here. And I'm going to begin by clicking on the Z-axis here. Left click on it. And I'm going to come up small ways. It doesn't really matter because we're going to constrain this here in a second. I'm going to left click on that Z-axis again. And then I'm going to come down again, and I'll left click there. Now your arc is going to look different than mine, and that's okay. The first thing that we're going to do is we're going to left click on the top of the arc, which is constrained to the Z-axis. And then we're going to click on the end of this 4 millimeter line segment that we created earlier. And we're going to constrain these 2 points to the same horizontal plane. Next, we're going to constrain the location of the other end of the arc. And we're going to left click on it, and we will set its height from the origin here. So left click on the origin, and we'll set the vertical distance here to 17 millimeters. And now we're going to set the distance of the end of this arc from the Z-axis. So left click on the end of the arc, and going to left click on the origin down here, and I'm going to set the horizontal distance here to 16.5 millimeters. So now the end of the arc has been constrained, and the arc can still move a little bit, so the location of its end can still move here. And it's not fully constrained here to the z-axis. So I'm going to fix that here. Left click on the end, left click on the z-axis, constrain to it. Okay, so now the arc is fully constrained, and we're going to add a second arc here in the center. So I'm going to grab the arc tool, left click on the z-axis, come down to the bottom of the arc we just created. Make sure that I'm right over top of the end of that arc, left click there. And I'm looking at the white crosshairs there. That's telling me where I'm going to click. So I'm going to come up to the end of that line segment and left click on that. And so that arc is now fully constrained. Now I'm going to add a feature down the length of the z-axis here. So I'm going to grab the polyline tool again. And I'm going to left click on the end of that larger arc, and I'm going to come down, and I'm going to hover over the z-axis and click, so that line is now constrained to the z-axis. I'm going to come out a little ways. We'll set the length of this in a bit. And then I'm going to come back up to the x-axis, and I'm going to left click on the x-axis to constrain it there. And now I'm going to right click to stop the polyline, and I'm going to right click to clear that tool. I'm going to grab the line segment tool now, and I'm going to come in to the end of this bottom line segment we created earlier. And I'm going to create a line segment that connects to the end of that. I can see here that it's vertically constrained. I'm going to left click on the line, and I'm going to constrain its vertical distance to 12.5 millimeters. So now that that line has been constrained, I'm going to add yet another arc. So I'm going to grab that arc tool, and I'm going to come down just below this original feature that we created, and I'm going to come down an arbitrary amount. I'm going to left click. I'm going to come up to the end of that line segment we just created. I'm going to left click on the end of it. And then I'm going to come all the way down, and I'm going to make sure that I terminate my arc by putting the crosshairs over top of this line segment over here that is locked to the x-axis, and click on it. So you can see that that line segment moved over. We're going to make sure that this bottom line segment here is constrained horizontally. So we'll set that to the horizontal. And we're going to set its width to 5 millimeters. And we can see that this line segment that follows the z-axis is no longer constrained there. So we're going to left click on it, left click on the z-axis, and constrain it back to the z-axis. Okay, so the last thing that we need to do now is we need to constrain the radius on this arc. So I'm going to click on the arc, and I'm going to come up here and choose constrain radius. And I'm going to set its radius to 19 millimeters. And we need to constrain the height of this central line here. So I'm going to left click on it, and I'm going to constrain it vertically to 30 millimeters. And so at this point, our sketch is fully constrained. And so I'll just pause here for a minute for anybody who's skipping ahead in the video who wants to just see what the final set of constraint measurements are. I think that's a pretty good representation of it. So now I'm going to close out of the sketch, and I'm going to click back on the model tab, and I'm going to take and sweep this, revolve this shape in 360 degrees. So up here is a revolution tool, and when I click on that, it gives me the option to choose through how many degrees I want to rotate it. Obviously, I'm rotating it through 360 degrees to create a full circular shape. So I'm happy with the way this looks, and I'm going to press OK. So now we have the basic shape of a wheel hub here, but we need to create a shape on the end of what will turn out to be the axle or where the axle connects, we need to create a shape here that will lock onto the axle. So left click on that top face, and we're going to create a sketch there and zoom into it. And I'm going to use the line segment tool, and I'm just going to create two random but vertically or horizontally constrained line segments here. I'm going to set them so that they're equal to each other. So left click on both of them and constrain equal. And now I'm going to grab the create arc tool, and I'm going to hover over the origin, left click on the origin, and then I'm going to come up to that top line segment and left click on it. I'm going to come down to the bottom line segment and left click on it. And now I'm going to create a second arc. So again, coming over to the origin, you can see when you hover over it, it turns a different color. Left click on the origin, come up to the top line segment, and again, go down to the bottom line segment. So now we have a closed shape, but we need to constrain the length and width of this thing. So I'm going to set both of these arcs so that they're equal to each other. So now we have some symmetry around the origin. I'm going to set the width of the top line segment to 4.4 millimeters. And I'm going to set the height, the distance between these two line segments, by left clicking on the end of those two line segments there. I'm going to set the vertical distance between them to 3.9 millimeters. So now this sketch is fully constrained, and I can close out of the Sketcher workbench here. There we are. Easy to read set of numbers. So I'm going to close out of this, and I'm going to pocket this feature. So I'm going to set the pocket here to 12 millimeters. And that's enough to grab the end of the axle on these TT yellow motors. I am going to create a small circular pocket right on top of this, though. So again, left click on the top of this pedestal here, and we're going to create another sketch. And I'm going to zoom in here, and I'm going to use the Create External Geometry reference tool, and I'm going to reference that left-hand edge. Right-click to clear my tool here. And I'm going to grab the Create Circle tool, and left-click on the origin, and I'm going to click on the vertex on the end of this arc here so that it's locked in place. Right-click to clear my tool, so now I have a nice circle that matches the shape that we created earlier. So I'm going to close out of this, and I'm now going to pocket this to a depth of 2 millimeters. So there we are. This makes it easy to grab onto the end of the axle on our motors. And this is a basic hub, and we're going to add some feature on the front here to make it look a little bit more like a mag wheel. So I'm going to hover over to this top face here and left click on it and create a sketch. And I'm going to grab the slot tool, and I'm going to come over the y-axis, left click to lock the slot to the y-axis, left click again to keep it there, and I'm just going to give it an arbitrary width right now. I'm going to click in the center on both of these arc pivot points here, so they're highlighted, and I'm going to constrain the vertical distance for this slot to 4.5 millimeters. Now, I just need to make sure that I do have auto remove redundance on here. I'm going to pull that in there again. So for whatever reason, these two arcs, that length didn't get set, so we'll try that again here. Constrain the vertical distance. And it's because I had the top arc selected. So there we are. Grab those two. Constrain that. There we are. It works that time. 4.5 millimeters. There we are. So it's locked in. And we will set it to a height of 9 millimeters above the origin, so we'll constrain its vertical distance there to 9 millimeters. And now we will constrain the radius of this to 1.5 millimeters. Okay, so the slot is fully constrained. We can close out of the Sketcher workbench, and we're going to pocket this shape to a depth of 21 millimeters, and that will take the pocket all the way through the hub. And I'm going to use the polar pattern tool, but to do that I must select the inside faces of the shape that I want to use with that tool. So I'm holding down Control and I'm selecting on each one of these faces. So all of the faces are selected, and I'm now going to use this polar pattern tool. Oh, looks like I deselected them. Let's try that again. One more time. There we go. And we're going to set that to 5. There it is. So we now have 5 of those slots. And the next thing that we're going to do, if we wanted, we could just send this to the 3D printer now. We've got a pretty nice looking hub. We're going to add some text to the outside of our rim here. Now you could add the text here, but the 3D printer, depending on the type of 3D printer you have, it may be challenging for the 3D printer to get nice looking text here. So just as an example of how to create text on a feature in FreeCAD, we're going to choose the outside of the hub here. And when your rubber tire is on, of course, this won't be seen, but you will have learned how to create text, and you can move it to any face of your hub that you wish. So this is just an example of how to do it. So I'm going to select this large outside surface on the hub, and I'm going to change my workbench now over to the curves workbench. Now the curves workbench isn't installed by default in FreeCAD. So to get the curves workbench, you've got to go up to Tools and go down to the Add-on Manager. And you've got to search for the curves workbench. And when you do, you'll find it here. Now, obviously, I already have it installed, but you click on it, and there'll be a button there that lets you install it. And then you will need to restart FreeCAD. So make sure you save your work first. You'll need to restart FreeCAD before the curves workbench shows up here in the list of workbenches. So mine is already installed, so I'm now going to bounce over here to the curves workbench. And again, I've got this one face selected. I'm going to come up here to the tool that says Sketch on Surface and click on it. Now, if you're not on the Model tab, you won't notice this, but we are on the Model tab. So when I click on Curve on Surface, or Sketch on Surface rather, I get this new Sketch on Surface feature show up here in the Model tab. And when we open it up, there is a mapped sketch. So we're going to double click on it, and I'm going to zoom out so that we can see it. And what we have is we have a rectangle using construction geometry that represents the width and length of the face spread out into 2D. And right now, this rectangle is locked to the origin, and the wheel hub is hiding it. So I'm going to use the View Section tool to move away most of the hub. I'm going to zoom into the origin here. And what I want to do is I want to remove the constraint that's locking this rectangle to the origin. And I've clicked on the background here. I'm making sure that I don't have anything selected. When I click on this top constraint here, you'll notice that the origin slightly changes color. Now that is letting you know that this is the constraint that's locking that rectangle to the origin. So I'm just going to delete this constraint, and you can see the origin showed back up now as a red circle. And I will now be able to move this rectangle wherever I'd like. And the reason for wanting to do that will be clear here in just a moment. I'm going to close out of the Sketcher workbench now, and now I'm going to jump over to a different workbench. I'm going to jump over to the draft workbench. And when we do that, we have a whole collection of new tools. But the tool that we're most interested here in is the shape string tool. So create a shape from text. So I'm going to click on this tool, and this is going to be a little bit challenging because I'm using a Linux operating system. I'm using Ubuntu, and you may be using something different like Windows. We have to first set the font that we want to use for writing our text. And unfortunately, at the moment, FreeCAD doesn't just show you a list of installed fonts. You have to figure out where the fonts are on your computer. Now, on Windows, you're going to have to go, when you click on this box on the right-hand side, in Windows, you would have to click on your C drive, then you would have to click on the Windows folder, then you would have to find the fonts folder, and then you would have to find a font inside the fonts folder. But there's another way that we can do this, and one that's going to be maybe a little bit easier to do. And what we're going to do is we're going to go to the internet, and we're going to go to Google, and we can just type in download Ubuntu font. And when we do this, we can go to Google Fonts, and here is the Ubuntu font. So just click on Get Font, and when you do that, it will end up in your Downloads folder. On Windows and on Linux, or in Ubuntu at least, you can right-click, and there'll be something that says Extract or Extract All or Extract Here, something like that. And when you click on that, it will extract the contents of the Ubuntu zip file into a Ubuntu folder. And here we have a number of TrueType fonts, and we're going to be using the Ubuntu regular TrueType font. So that's just sitting in my downloads folder right now, and it will probably sit in your downloads folder. So we're going to go back over to FreeCAD now. And here in the font file, instead of trying to navigate to the system fonts, instead, I'm going to go to the downloads folder, and I'm going to go into that Ubuntu folder, and I'm going to click on Ubuntu regular and say open. So now the path to that font will show up here. And this string here that says default, that's going to be the text that shows up that you're going to put on your wheel hub. And so I'm just going to write SparkBot here. And this is going to be the size of the text. And I'm going to set this to a height of 8 millimeters. The last thing that we're going to do here is, as I move my mouse pointer around on this grid here, you can see that the X and Y coordinates change. I'm going to click up here. It's sort of in the middle of quadrant 1. And now when I move the mouse, those numbers don't change. And I'm going to choose OK. And so SparkBot shows up here in the corner. Now I'm going to go back over to my map sketch that we were looking at earlier. And now you can see that being able to move this rectangle with its construction geometry is quite helpful, because we want our text to be somewhere in the middle of this rectangle, and the draft workbench makes it somewhat challenging to precisely locate where the text is going to be on that grid. So instead of worrying about how to position the text in the box, we'll just move the box so that it's wrapped around the text, and that's a much easier way of doing this. So now that we've got the text positioned, we can close out of that. And we don't actually need to see this shape string anymore, so I'm going to hide it by clicking on the picture of the eyeball beside it. I can bring it back anytime I want by clicking on that eyeball. And I'm going to leave the draft workbench now. I don't really want to see this background grid, so to hide the grid, I can come to the bottom of the screen here, and there's a toggle button that will allow us to toggle off the grid. And now when I look at the side of my hub, I can't see the text. So it seems like the text hasn't actually been mapped onto the outside of the hub. But what I have to do is you have to click on Sketch on Surface, and here in the Data panel, we have a couple of options here, and we want to find Sketch on Surface here. And we want to come down to Extra Objects and click in there, and you can see a little box with 3 dots show up. Click on that. It's going to show you a list of shapes that are part of your part. And here's that shape string that we created earlier. So I'm going to left click on that and say OK. And then again, it looks like nothing's happening. I'm going to left click into the space with this part, and there we are. We can see that we have some text on the outside of that hub now. If you're wanting to change the orientation of the text, we have to do this up here on Sketch on Surface, and we're going to rotate it by changing the U and the V coordinates. So I'm going to click on this, and I will choose True, and I will click into the main window, and we can see that the font has changed, but now it's upside down. I'm going to come down to reverse V and do the same thing. And I'll click into the middle window, and there we are. So now our text has basically flipped or rotated 180 degrees. And this text right now is just a 2-dimensional representation of our text. And we need to engrave this text onto the wheel hub. So there are a couple of steps that we need to take. And I'll show what I'm talking about. If I come up here in the Model tab and I hide the body, you can see that this text is just 2-dimensional. Well, we need to make this 3-dimensional. First thing that we're going to do is in the Model panel, we again click on Sketch on Surface, and we're going to come down here to Fill Faces, and we'll set Fill Faces to True. And then the next thing that we're going to do is we're going to set the thickness of it to -0.5. And negative just simply sets the direction that the shape becomes 3-dimensional. If it was a positive 0.5, so if we're looking at this, and I set this to +0.5, then the text becomes 3-dimensional and will stand out from the hub. I want this shape to poke into the hub. So go back to that, change that to -0.5, and there we are. So when I hide the body, when I hide the wheel hub, I can see that it's still 3-dimensional text. Okay, so what we're going to do now is we're going to use the part workbench, not the part design workbench. So we're going to come in here, we're going to go down to part, and I'm going to, in the model panel here, I'm going to left click on body, I'm going to hold down control, and I'm going to left click on sketch on surface. And you can see that I got those two things selected. I'm in the part workbench, so I'm going to come over here to this Boolean tool called cut. And when I click on it, I am getting a combined shape where the text, the 3-dimensional text, has been removed, and a cutout is left where that text shape was. So that is how you can add text to a model that when it's 3D printed, the text will show up as an inset shape or an engraving into the shape, if you will. All right, and so this will work with the 60mm wheels that typically come with the TT motors. And if you've got a different size rubber wheel, then you could modify the dimensions of this hub to match the rubber that you're using.